Let's talk about the biology of adaptation, something called mitochondrial biogenesis. Now, when we are talking about exercise helping us alter the trajectory of aging, we are not talking just about burning calories or the surface level benefits of staying active. We are talking about fundamental biological upgrade. Think of your body as a complex machine that's beginning to slow down. To stay ahead of the curve, you cannot just clean the exterior. You have to install a faster processor and update the entire operating system. This is the biology of adaptation. This process starts at the cellular level with the mitochondria, the tiny power plants that turn food into energy that your body needs to survive. Now, exercise flips on a master sort of go signal called PGC1 alpha. Think of the PGC1 alpha as the foreman on a high-tech construction site. When you push your system, this foreman sends a message to build entirely new mitochondria and, just as importantly, improve how the old mitochondria are running. Now, this cellular expansion is the secret behind metabolic flexibility, which is your body's ability to switch smoothly between burning fat and burning carbohydrates, depending on the demand. Now, by upgrading these power plants, the mitochondria, you are making sure that your cells can meet the energy needs without accumulating the metabolic sludge, so to speak, that leads to disease. Now, while your cells are upgrading their hardware, your brain is running a neurological software update. This explains why in the first 4 to 6 weeks of a new strength training routine, people often see a massive jump in power even though their muscles didn't grow much in size. So the early strength is not from bigger muscle, it's your nervous system getting smarter. Your brain learns to recruit more muscle fibers, and at the exactly same time, it tightens the coordination between them. It's like updating the software on old computer. The hardware, right, the muscle, stays the same for a while, but the system becomes more powerful and stable because the code is now running more efficiently. Now, for the software to work, it needs a healthy sort of metabolic sink to run on, right? In other words, it needs your skeletal muscle. Muscle is one of your most important metabolic organs because this is where your body parks the glucose that you eat. In fact, a huge chunk of your blood sugar is handled by your muscles when insulin is doing its job. This is where we run into the challenge of sarcopenia or age-related muscle loss. When you lose muscle, you literally lose your storage space for fuel. This is the primary reason why muscle loss is so tightly tied to insulin resistance and type 2 diabetes. Your body simply has fewer places to, quote, park and use the glucose, leaving it to cause damage in your bloodstream, right? Now you have too much blood sugar circulating. Now, to maintain this hardware, we have to overcome a hurdle called anabolic resistance. See, as we age, the same dose of protein that we eat simply does not turn on muscle building as easily as it used to. And this is why the standard recommended dietary allowance for 0.8 gram of protein per kilogram of body weight is usually not enough for older adults. We're talking about adults over 65. That's where most of the studies have been done. So to really protect your sort of metabolic sink, as we call it, the human evidence points to a much higher protein target, and the baseline is usually somewhere between 1 to 1.2 gram of protein from diet per kilogram of our body weight for a day. And for those at higher risk for muscle loss, the range can be even higher, somewhere between 1.2 to 1.5 gram per kilogram for a day. Now, this is making sure that your body has the raw material that it needs to complete all the sort of hardware upgrade, right? Now, the beauty of this adaptation is that it acts as a systemic polypill. Now, this is an interesting concept that, if you think about it, is just really amazing how nature has designed us, right? Because we can take a simple drug, medication that will target one thing, for example, blood pressure. Now, exercise is sort of pleiotropic. It's a fancy word that means that it hits many systems at once. Now, there was a landmark meta-analysis published in the British Medical Journal that compared exercise trials to medications for things like heart disease and stroke recovery. Now, the big takeaway from those studies was that in many settings, the survival benefits of exercise were statistically similar to certain medication. One of the reasons for this is something called BDNF, which stands for Brain-Derived Neurotrophic Factor. Think of BDNF as sort of Miracle-Gro for your brain and nervous system, which makes exercise a multi-system update that drugs simply cannot match. But it doesn't make the brain just grow. It actually helps your brain cells, called neurons, stay alive, strengthens the links between them, and lets those links reshape themselves based on your experience. This reshaping process is called neuroplasticity, and it is super important for your memory, learning, coordination, and your ability to win back skills after you have been sick or injured. Now, just a single session of cardio or aerobic exercise can temporarily boost the BDNF floating around your body, especially when your workout reaches at least a medium effort level. Now, that boost can create temporary sort of plasticity window, where your nervous system is basically much more open and ready to take in the information and practice that come right after it. Now, when it comes to your thinking skills, what this means is pretty straightforward. Exercise can help get your brain ready to learn, focus, and make more memories. Before you try to learn a new language, study a tough subject, or practice an instrument, or do any other heavy brain sort of work, taking a fast walk or bike ride can put your brain in a perfect biological mood to learn better, pretty much. So in the long run, doing a regular cardio is linked to better memory, and it protects the hippocampus, which is the specific part of your brain, which is really deeply involved in making new memories. Now, in one big study of older adults, a year of aerobic exercise actually grew the front part of the hippocampus by about 2%. And those changes were tied directly to changes in their BDNF levels. Now, this doesn't mean that BDNF is doing all the work by itself, but it does give us sort of scientific explanation for why physical exercise changes an aging brain in a way that just sitting around doing just crossword puzzles just cannot do. But BDNF is not only about being book smart or your thinking skills. Movement itself actually has to be learned on its own. For example, when you start lifting weights, work on your balance, recover from a stroke, or get back into action after some injury, your nervous system has to learn which muscles it needs to use, how hard to squeeze them, and in which order to use them, and how to fix mistakes using signals that are sent back from your joints and muscles. That's why physical rehabilitation is not just about rebuilding damaged tissue. It's also about rewiring the movement programs inside your nervous system. Now, there are some interesting studies in humans that show basically that doing cardio exercise close to the time when you are practicing physical skills can really help you learn and remember that new movement better. The explanation for that is basically that the temporary boost in the BDNF level and other exercise signals make your movement networks way more open to the specific practice that follows that exercise. So in specifically rehabilitation world, this could mean doing some cardio before you practice walking, before you do work on your balance, before you're retraining your arms, or do any other activity where you are pretty much learning how to move. Now, this doesn't mean that cardio itself magically fixes the lost skills. The actual rehab practice is what gives your nervous system the information that it needs to learn. Cardio just helps to set up the best biological environment for that learning to happen. You can look at it this way. Aerobic exercise opens up the software so that it can be edited, while your physical therapist, your rehab exercises, or your practice moves decide what new information gets typed into the program. Now, there might also be a link to the quick brain and nerve gains that you see when you first start lifting weights. Now, during the first few weeks of strength training exercises, you often get stronger before your muscles actually grow bigger. And that's because your nervous system gets better at calling up and organizing the muscle fibers that you already have. Now, since the BDNF is biologically capable of supporting these kind of nerve changes, it might be helping out with that process too. However, this difference is super important. We don't have strong proof right now that doing cardio before regular weightlifting session pretty much builds bigger muscles or make you stronger in the long run just because you increase your levels of BDNF. So you shouldn't treat BDNF like muscle building hormone, and there is no reason to get yourself tired with hard cardiovascular exercise before lifting weights so that you can chase the temporary spike in the blood levels of the BDNF. Okay? So for normal workout with weights, simple short warm-up with any kind of cardiovascular exercises is plenty. But when your main goal is learning is you're learning basically complicated movements like balance training, walking rehabilitation, certain things even in physical therapy, or mastering some tricky, highly coordinated exercises. Doing a medium cardio session before you practice can be actually much more useful because your central goal at that point is brain learning rather than maximum muscle power. So the big practical lesson here is much broader than just exercise boosts your levels of BDNF. Regular cardio helps to keep the biological machinery of your memory and brain healthy, running smoothly, right? Then lifting weights and practicing skills give the highly adaptable nervous system something meaningful to practice and learn. Now, together, they don't just protect how much strength your body can produce as you get older, as you age. They also protect your brain's ability to control that strength, to learn new tasks, fix errors, and heal itself when something goes wrong. Now, we can also further alter the trajectory by using controlled environmental stress. One of the most studied example of this environmental stress is heat from sauna. To understand why heat might matter, we first need to talk about proteins. Now, proteins are working tools of every cell, but they only function when they are folded into the correct shape. Now, as we age, as we get older, proteins become sort of more likely to lose that shape, become damaged, or even stick together. Now, this gradual loss of protein quality control is one of the hallmarks of aging. Misfolded proteins are specifically important in the brain. Amyloid beta and tau are involved in Alzheimer's disease, while the alpha-synuclein is involved in the Parkinson's disease. The body has its own sort of defense system against this damage, and it's called heat shock proteins. Think of them as molecular repair workers. They help to stabilize vulnerable proteins, refold proteins that can still be repaired, and pretty much help send the proteins that are damaged beyond repair to the cell's recycling system. Now, heat is one way to activate this response. When body temperature rises, cell recognizes the stress and increases the heat shock proteins and other protective pathways. But this needs an important clarification here, okay? Sauna has not been proven to remove amyloid plaques, clear the tau from the human brain, or prevent Alzheimer's disease through the heat shock proteins, as some people tend to claim. The mechanism is biologically plausible, but the direct chain from sauna to better protein clearance to prevention of dementia, all of this has not been really at this point demonstrated in humans. So the strongest long-term evidence really for the use of sauna comes from the traditional Finnish sauna studies. In one of these studies that followed more than 2,300 middle-aged men for quite a long time, about 21 years, those that were using sauna for about 7 times per week, anywhere between 4 to 7 times per week, had about 40% lower rate of death from all cause that men that were using the sauna only once per week didn't get. The same group also had lower rates of sudden cardiac death and fatal cardiovascular disease. Now, later research in this population found that men using sauna for up to 7 times a week had approximately 65% lower rate of diagnosed dementia and Alzheimer's disease. Now, these are impressive numbers, but we have to keep in mind that these data came from observational studies. The researchers that did the study try to adjust and take into account the level of exercise, smoking, and the blood pressure of those participants, if they had diabetes or not, and other risk factors. But they could not eliminate every single difference between frequent and infrequent sauna users. So the results do show strong association, but not a clear proof that sauna alone was responsible for all these lower risks that we just mentioned. Now, the benefits probably extend far beyond the heat shock proteins that are formed during the sauna exposure, because during a sauna session, your blood vessels in the skin opens up, widen up, right? The blood flow increases and the heart works harder. After the sauna, blood pressure often falls down. So with repeated use, this itself may improve blood vessel function, arterial flexibility, heat tolerance, and blood pressure regulation. It may also affect inflammation, stress, and the autonomic nervous system function. So protecting the brain's blood supply may just be as important as protecting the proteins inside the brain cells. Now, a small randomized trial can give us some more practical guidance that looked at this stuff. So adults in that study with cardiovascular risk factors exercise 3 times per week for about 8 weeks. One group in that study added 15 minutes of traditional sauna after each workout. And this was compared with exercise alone. Another group that exercised and added sauna. And these guys had actually greater improvement in cardiovascular fitness, systemic blood pressure, and even total cholesterol. So this makes basically the post-exercise sauna exposure one really practical way to include the heat exposure. The workout and sauna can be completed in one visit, and the heat does not really interfere with the main exercise session, right? So for someone beginning to do this kind of practice, maybe 5 to 10 minutes once or twice per week is reasonable, right? When they sort of develop more tolerance, they can probably increase this to around 15 to 20 minutes, or even 2 to 3 times per week. The 4 to 7 times per week schedule that we saw in that Finnish study should not really be looked at or treated as a proven prescription, right? It was simply the group with the highest reported sauna use. And we don't know the exact minimum or ideal dose that would apply to longevity. The traditional Finnish sauna really has the strongest long-term evidence. And it normally uses high temperature, which is usually around 80 degrees Celsius or 176 degrees of Fahrenheit, with relatively low humidity. Now, what about steam rooms and infrared saunas? Steam rooms use lower temperature with nearly complete humidity, while infrared sauna usually operate at still lower air temperature and heat the body more directly. Now, both of them can create meaningful heat stress to the body, but neither one has the same decades-long sort of mortality and dementia evidence as we saw in the traditional Finnish sauna. Now, what about hot water immersion, which is another option? So-called hot baths can really raise your temperature and increase circulation and activate some of the same heat response pathways. But exercise itself also increases heat shock proteins and cellular repair. So sauna should not really be considered sort of additional tool, at least not the way that it creates the effect that would replace standard exercise. It sort of add-on, not really a replacement for that. Now, are there any supplements or any other methods that can improve the production of the heat shock proteins? There is no really proven supplement, fasting method, or even the cold plunges that will multiply the sauna's effects on the misfolded proteins based on the research data that we have available at this point. The cold water exposure after the sauna may feel good, but it has not been shown to increase the longevity benefits at this point. The most useful combination correctly supported by human evidence is simply exercise followed by tolerable period of heat. Now, another question that we may want to ask is how long does the protection from the heat shock proteins last? So the response to the heat shock, right, when you're exposed to either the sauna or the hot bath, that response begins during that exposure and shortly after the exposure. But there is really no exact human timeline showing how long does the protection against protein damage last, right? Some heat acclimatization changes begin fading after 1 or 2 weeks without additional heat exposure. But those studies measured temperature control and athletic performance, not really looking at the benefits on Alzheimer prevention. Missing several days does not suddenly erase the benefits, and the long-term studies reflect a repeated habit maintained for years, not really a short treatment that must be performed every single day. Now, there is also one important consideration for men, and that's the possible effect on male fertility. In one very small study, 10 healthy men used a traditional sauna for 15 minutes twice per week for 3 months. And when they look at their sperm count, the movement of the sperm, and the mitochondrial function, and the DNA packing, they did see worsening in all of these. Now, the effect reversed within 6 months after stopping this, but yeah, it took pretty much 6 months to do that. Now, this does not prove that occasional sauna causes infertility, but men who are actively trying to conceive should be cautious about frequent testicular heat exposure. And one way to really address it is to use cold pack on the testicles during the sauna. Obviously, you cannot do that with the hot baths. So, how much does sauna really add to longevity lifestyle? Well, it does not definitely belong in the same category as exercise, avoiding tobacco, controlling blood pressure, and maintaining metabolic health, or even getting adequate sleep. Those remain the foundations, and we spoke about them in a previous podcast. But once those foundations are in place, sauna may provide another useful layer. It sort of creates a controlled cardiovascular and cellular stress without impact on the joints. The goal is really not the highest temperature or the most sweat. It's pretty much tolerable 15 to 20 minute exposure, repeated consistently enough to become a long-term habit. Now, finally, let's talk about something that's a little bit different, and that's the fact that none of this software update can be really fully saved without adequate sleep, right? So let's talk about sleep. Sleep is not simply a period when your body sort of shuts down. It's really active maintenance period. The brain organizes information during sleep. New movement patterns are strengthened. Damaged tissues are repaired. Hormones are regulated. and the cellular waste is really pretty much moved out of the brain. Think of exercise and learning as entering new information into the computer. And sleep is when the system really saves the file, organizes it, removes unnecessary material, and prepares the machine to work again the next day. Now, you can perform excellent workout or rehabilitation session, but if sleep is repeatedly cut short, some of that adaptation may never really fully be stored, right? So sleep occurs, we have to think about sleep as several cycles. During the sort of non-REM sleep, the brain gradually moves into the deeper, slow wave sleep. During the REM cycle, the rapid eye movement cycle, the brain activity becomes more active again while most of the body's muscles remain temporarily quiet. Now, these stages overlap in their functions, but each seems to have particular strengths on its own. For example, deep sleep is specifically important for the physical recovery, immune regulation, memory stabilization, and the brain's, as we just talked about, the cleaning of the waste from the brain. While the rapid eye movement cycle, the REM cycle, is really strongly involved in emotional processing, creative problem-solving tasks, and really connecting new memories and learned skills with information that is already stored in the brain. Now, deep sleep is concentrated more heavily during the first part of the night, while the REM part of the sleep becomes progressively longer towards the morning. And that's why sleeping for only 5 or 6 hours is not simply just a slightly shorter version of a complete night. If you're regularly cutting off the final hours of your sleep, you may lose a large portion of your REM sleep, even if you receive some deep sleep early on at night. Now, this brings us to the sort of glymphatic system, which is the brain's internal waste cleaning network. Now, you can imagine the rest of the body having equivalent to that in its lymphatic system, right? That helps to collect the excess fluid and the cellular waste from our whole body. The brain uses sort of related but very specialized pathway to accomplish this. The cerebrospinal fluid that moves along the spaces surrounding the blood vessels in our brain exchanges with fluids around brain cells and helps carry the soluble waste towards drainage pathways outside the brain. Now, during the non-REM cycle, slow electrical waves in the brain becomes linked with changes in the blood flow and large waves of cerebrospinal fluid. These coordinated movements really appears to create better conditions for waste to move through and out of the brain tissue. Now, among the substances that are involved in this process are the amyloid beta and tau, which are the same proteins that can accumulate abnormally in Alzheimer's disease. Now, we do have some studies in people that gives us pretty good reasons to take this information pretty seriously. The reason I'm saying it is because, for example, in one experiment, a single night without sleep was followed by increased measurable amyloid beta in areas including the hippocampus and thalamus. Other studies have found that total sleep deprivation or even the selective disruption of the deep slow wave sleep can raise the amyloid and tau related proteins in the fluid surrounding the brain. Now, Obviously, this doesn't mean that one poor night causes Alzheimer's disease, right? These were short laboratory experiments measuring the temporary biological changes. Again, these studies don't prove that one night's sleep that's not perfect creates permanent plaques or leads directly to dementia. The concern is the repeated poor sleep over many years. The relationship can actually work in both directions. Poor sleep may interfere with the clearance and regulation of abnormal proteins, while the early changes in the aging brain may actually damage the systems that control sleep. Now, this can create a cycle in which the poor sleep contributes to declining brain health, and the declining brain health makes normal sleep really increasingly more difficult. So the glymphatic system is important part of the whole longevity story, but it is not the only reason that sleep matters. Sleep also helps preserve memory, stabilize the neurological gains from the rehabilitation and strength training, as we talked about, support muscle repair, and maintain healthy glucose control, which I discuss in different video. We need to understand that sleep is not a passive break from the work on improving our overall health and improving our chances of healthy longevity. Sleep is the nightly period in which much of that work is completed. Exercise creates the signal, nutrition supplies the material, learning writes the new program, and sleep helps to save the changes, repair the hardware, and clear away some of the waste that's left behind. So the key to all of this is finding the minimum effective dose. You don't have to crush yourself to trigger all the signals that we talked about today. The data suggests that biggest drop in health risk for strength training happens with just 30 to 60 minutes per week. More can still help, and performance and strength can improve, but the survival benefits tends to level off beyond that sort of sweet spot. And as we cross the age 50, the goal is to trigger the foreman that we talked about, the PGC1 alpha, without hitting the injury ceiling. Because the most successful adaptation is not the one that is the most intense. It's the one that provides the necessary stimulus while respecting the system's capacity to recover. And that's all I have for today, and I'll see you in the next part of this podcast.